Now we will discuss about object placed beyond the center of curvature on the principal axis. Okay, once you observe the figure 13, this is biconvex lens. So on this biconvex lens, object is placed beyond the center of curvature. If the object is placed beyond the center of curvature, which type of image is formed? A real image, inverted image, and diminished image will form. Okay, so a real, inverted, and diminished image is formed on the principal axis between the focal point and center of curvature. Between the focal point and center of curvature. So in the figure 13, we have chosen two rays. So what is that first ray? First ray is passing parallel to the principal axis and passing through the focus, and the second ray is passing through the optic center to locate the position of the image. Okay, so here object is placed beyond the center of curvature. Object is placed beyond the center of curvature. Then one ray traveling parallel to principal axis pass through the focus. Okay, and another ray is pass through the optic center. These two rays are converge at one point. At the point of this convergence, the image is formed that we can observe in figure 13. Okay. In the previous class we discussed about the image formation by convex lens. For that we discussed ray diagram, and that one situation object at infinity completed and the object at behind the center of curvature completed. Now we are discussing one more situation, object placed at the center of curvature. If the object is placed at the center of curvature, when the object is placed at the center of curvature, then one ray is traveling parallel to principal axis pass to the focus, and another ray is passing to the optic center. These two rays are converged at one point. From the point of convergence, draw one line onto the principal axis, that is image. Here when the object is placed at the center of curvature C2 on the principal axis, you will get an image at C1, that is real image, inverted image, and same size of that object that we can see in figure 14. Next, one more situation, object is placed between center of curvature and focal point. When the object is placed between center of curvature and focus, you will get an image. So that is real image, inverted image, and magnified image. This image is formed beyond the C1. Okay, so here object is placed between C and F. So here one ray traveling parallel to principal axis and pass through the focus. Second ray is passing through the optic center. This does not deviate its path, it follows the same path. The first refracted ray and the second refracted ray, the two are converged at one point. At the point of convergence, the image will form. Okay, so this image is real image, inverted image, and magnified image. Next, one more situation, object is located at the focal point. Here the object is located at the focal point. Here we have chosen two rays, one ray traveling parallel to principal axis pass to the focus, another ray is passing to the optic center. Okay, so when the object is placed at the focus, the image will be at infinity. Okay, so the image formed at infinity distance away, so we cannot discuss the size and nature of the image. Okay, now object is placed between focal point and optic center. If we place an object between focal point and optic center, we will get an image which is virtual, erected, and magnified. So here the object is placed between focus and here the object is placed between focus and optic center. So one ray traveling parallel to principal axis pass to the focus, another ray is passing through the optic center. These two rays are not converge. Okay, if you hold the screen front, image is not formed on the screen. If you hold the screen back side, then also the image is not formed on the screen. So if we increase the screen distance, also image is not formed on the screen. So if we extend the rays, reflector rays backward, that appears to be converged at one point. At that point of convergence, the image is forming. That image is virtual image, erect image, and magnified image. So if we place the object between focus and optic center, we will get an image which is virtual, erect, and magnified. So from the ray diagrams shown figure 17, you will notice that the image formed is a virtual, erect, and formed on the same side of the lens where the object is placed. So the size of the image is larger than that the object. The size of the image is larger than that of the object. It is a magnified image. So in the above situation, the image formation, we understood two things. The image format is virtual, we can see it with our eye. In all other cases, the image is real, which we cannot see with our eyes, but we can view it if the image is captured on a screen. So if the image is formed on the screen, then we can see. So a magnified virtual image is formed on the same side of the lens when the object is placed. So thus the image you are seeing through the lens is not real, it is a virtual image of the object. So the particular behavior of a convex lens help us to construct a microscope which gives a magnified image. So you might remember that the magnification of a virtual image is possible only when the object is at a distance less than the focal length of a lens. So here in this situation, this particular behavior of a convex lens help us to construct the microscope. Why? Because it is giving magnified image. So this magnification of a virtual image is possible only when the object is at a distance less than focal length of a lens. Okay, till now we have drawn the ray diagram for the various position of objects placed on the principal axis using a convex lens. So now we will try to draw the ray diagram for an object placed between C1 and F1 for a concave lens. We are discussing about the ray diagram when the object is placed between C1 and F1 for a concave lens. Okay, observe the figure. Verify your ray diagram with the ray diagrams. Okay, so here one object is placed between C and F between the concave lens. Okay, so verify your ray diagram with the ray diagrams. We have drawn for a convex lens. See the figure writing. Try to draw the. Okay, so here biconcave lens is there, no? So object is placed between C1 and F1. So from the object, one ray is traveling parallel to principal axis. After falling on the biconcave lens, it is diverging. One more ray, second ray, is passing through the optic center. It does not deviate. It follows the same path. Now extend the refracted rays backward. First refracted ray extend backward. Okay, that first refracted extend backward, that is converge the ray which is passing through the optic center at one point. From that point, draw one line onto the principal axis, that is image. So here the image will form. Okay, this image size is smaller than the object size. Like that, by the concave lens we can get the image. Till now we discussed the ray diagrams for the image formation by lens. Okay, yes or no? Yes, we discussed. Okay, so for the ray diagrams, when we change the position of an object, means on F we kept object, sometimes between F and C we kept object, sometimes on C we kept object, sometimes beyond the C we kept object, sometimes between P and F we kept the object. Then image position also changing or not? When we place the object on C, image is formed on the C. When we place the objects beyond the C, image will form between F and C. If we place the object between C and F, image is formed beyond the C. Like that we got, no? So it is correct or not? That we can find out with the help of experiment. To perform this experiment, we need biconvex lens, V-stand, screen, table, meter scale. Okay, na? First, find the focal length of a lens. Okay, how can you find the focal length of a lens? To find the focal length of a lens, take a V-stand and place it on the long table at the middle. Take a V-stand, place it on the long table at the middle. Now place a convex lens on the V-stand. Okay, place this convex lens on the V-stand and imagine the principal axis of a lens. Now light a candle and ask your friend to take the candle far away from the lens along the principal axis. Okay, so now we took V-stand, we placed that V-stand on the table, and we took convex lens and we placed that convex lens on the V-stand, and we imagine the principal axis of a lens and light the candle. Ask your friend to take the candle far away from the lens along the principal axis. Now adjust the screen. Okay, here we can use the sheet of white paper has a screen, otherwise we can take screen also. Adjust the screen which is on the other side of a lens, means in the middle lens will be there, lens one side candle will be there, lens another side screen will be there. Okay, so adjust the screen which is on the other side of a lens until you get the image on it. Okay, so here measure the distance of the image from the V stand of the lens, that is called as image distance, and also measure the distance between the candle and stand of the lens. This is object distance. Record the values in table. Okay, so middle lens will be there. Next, one side of the lens candle is there, another side of a lens screen is there. Okay, till you get the image of a candle on the screen, move the screen front and back, where you will get the clear image. Then measure the distance between the image, means screen and stand, that is image distance, that is focal point. For example, if you place the candle at 30 centimeter distance, then you will get okay, so if you place the candle in front of a lens, then at 30 centimeter distance you will get the image. That 30 centimeter is focal length of a lens. Okay, now place the candle at the distance 60 centimeters from the lens. Now place the candle at 60 centimeter distance from the lens. Try to get the image of the candle flame on the other side of a screen and adjust the screen till you get the clear image. Okay, then measure the image distance. Okay, how can you measure the image distance? The distance between the candle and screen is called as image distance. The distance between the image and lens is called as, means screen. On screen image is forming. The distance between the screen and lens is called as image distance. The distance between the candle and lens is called as object distance. Okay, you can note that values. So with the help of this convex lens, we will get different types of images. No, so how we will get, and means enlarged image, magnified image, diminished image, like that we will get. No, virtual image we will get. No, that correct or not? Now we will discuss. Okay, so see here. First, take a V stand and place the convex lens on its stand. So first take V stand and place the convex lens on this stand. Next, imagine the principal axis of the lens. Now light a candle. Ask your friend to take the candle far away from the lens along the principal axis. We use a screen because it forms real image generally, which will form on the screen. Real images cannot be seen with eye. Adjust the screen on other side of a lens until the clear image form on it. Measure the distance image from the stand and also measure the distance between the candle and the stand of a lens. Now place the candle at a distance of 60 cm from the lens such that the frame of the candle light falls on the principal axis. Try to get the image of the candle flame on the other side of a screen. So here, first take a V stand. On that V stand, place biconvex lens. Okay, place this V stand biconvex lens on the table. Okay, next with the help of tape or scale, measure the values from 10 centimeters to 120 centimeters, like that. Okay, your wish. Now take a V stand, and that V stand place the convex lens, and other one side of the convex lens place the candle. Okay, and another side of a convex lens V stand place a screen. Okay, now place the candle at 60 centimeter distance, and 60 centimeter distance. So from the candle rays falling on the convex lens, pass through the convex lens and converge at one point, form image on the screen. Adjust the screen till you get the image of the candle on the screen front and back. So if the candle is at 60 centimeter distance, then if you place the screen at 60 centimeter distance, then the image will form there clearly. If you hold the screen before the 60 centimeter distance, no clear image will form. If you hold the screen after the 60 centimeter distance, no image will form. Next, next to place the object at candle at 50 centimeter distance. So hold the screen front and back, then you will get the image at 75 centimeter distance. Okay, now keep the candle at 40 centimeter distance. Hold the screen front and back till you get the clear image. If you hold the candle at 120 centimeter distance, like that, then the image will form on the screen clearly. Now hold the candle at 30 centimeter distance. Then move the screen front and back. No image will form on that. If you move back, no image will form. If you move back, no image will form. If you hold the screen at so much distance, then the image will form. then that is called as image is at infinity. Now hold the screen, hold the candle, okay, place the candle at 20 centimeter distance. If you place the candle at 20 centimeter distance, hold the screen front and back till you get the clear image on that. At 60 centimeter distance, the image will be formed. Okay, so here ray diagrams we discussed. In the ray diagrams, if the object placed on C, image will form on C, that is same size, like that. If you place the object beyond the C, image will form it between F and C. If you place the objects between C and F, image will form beyond the C, enlarged image, like that we discussed. If the object is at focus, then what happens? If you place the object at focus, image will form at infinity, we discussed. If the object placed between F and P, then the image is formed is virtual image, that size is less, like that we discussed. That is yes or not once we compare. So here, once you observe the table, object distance is there, image distance is there, focal length is there, characteristics of image are there. Okay, there are not there. Okay, so here the object distance is 60 centimeters. Okay, object distance is 60 centimeters, means image is also formed on the screen at 60 centimeters. Okay, so object distance 60 centimeter, image distance 60 centimeters. Same means object, when the object is on C, then the image is also on C. Yes or no? Like that. This situation is matching with that situation. So this is same size image, real image, inverted image. Okay, now object center of curvature means that is 60 centimeter, means what is the focal length? Focal length is half, means focal length 30 centimeter is there. Yes or no? Focal length 30 centimeter, center of curvature 60. Focal length is 30 centimeter, center of curvature 60. Now place the object at 50 centimeter distance. If you place the object at 50 centimeter distance, then where is the image will form? Image will form at 75 centimeter distance, means object distance is 50 centimeter, means object is placed between C and F. Why? Because C is 60 centimeter, F is 30 centimeter, means object is placed between C and F, that is 50 centimeters. If the object is placed between C and F between 50 centimeters, if the object is placed between C and F, then image will form beyond the C. So then what is the image distance? 75 centimeters, means beyond the C, means C is 60 centimeters, beyond the C means more than 60, no, means image distance is 75 centimeters, like that it will form. Okay, so that is enlarged image, real image, inverted image, once you compare with your ray diagrams. Okay, next, object is at 40 centimeter distance. Object is at 40 centimeter distance, means object is placed between C and F. Object is placed between C and F. Object is 40 centimeter distance, means object is placed between C and F. Why? Because C is 60 centimeter, F is 30 centimeter. So 40 centimeter will come between 60 centimeter and 30 centimeters. No, that's fine.